Hello, viewers. Welcome to my YouTube channel, Mathematics Medicine. So in today's video, I want to show how this Gaussian integral from negative infinity to positive infinity of e raised to the power of negative x squared equal to the mysterious number, the square root of pi. So that is our goal for today. So solution. So I'm going to let I be equal to that integral from negative infinity to positive infinity of e raised to the power of negative x squared dx. So the next thing I'm going to do is to square the integral. So if I square the integral, I'm going to have I squared equals integral from negative infinity to positive infinity of e raised to the power of negative x squared dx. And I'm going to introduce another variable that is integral from negative infinity to positive infinity of e raised to the power of negative y squared, the y. So that's the double integral. So we're going to have I equals integral from negative infinity to positive infinity, and another integral from negative infinity to positive infinity of e raised to the power of negative x squared multiplied by e raised to the power of negative y squared dx dy. So if we apply the law of indices here, we're going to have I square, sorry, this is I square. So we're going to have I square equals integral from negative infinity to positive infinity of negative infinity to positive infinity, then of e raised to the power of negative into bracket x squared plus y squared dx. Okay, so the next thing I'm going to do is to use the polar coordinates. That is, I'm going to put x to be equal to r cos theta, then I'm going to put y to be equal to r sine theta. Okay, so where r is greater than or equal to 0 and is the distance from the origin, are we together? And then also theta is in between 0 and 2 pi, that is from 0 to 2 pi, and is the angle for the x axis. Okay, then so what we want to do is to change the variable x comma y to a new variable r comma theta. So that is the little rectangle area, the x, the y. So on the Cartesian coordinate, so it's going to become a curved wedge in the polar coordinates. Are we together? That is, how do we rewrite the x, the y in form of the r, the theta? So how do we write the x, the y in form of the r, the theta? So I will be using the Jacobian determinant of the transformation. So that is what I will be using to find, to express the x, the y in terms of the r, the theta. Okay, guys. So here's the formula for that. So we know that the x, the y is equal to the determinant of the Jacobian multiplied by the r, the theta. And what is the determinant of the Jacobian? We know that the Jacobian matrix equals the x, the r, then the y, the r, then we have the x, the theta, then we have the y, the theta. Okay, so then if we find the determinant, so this means the x over the r multiplied by the y over the theta, then minus the x, the theta, then minus the y, multiplied by the y, the r. Okay, multiplied by the y, the r. So that is the formula. So guys, so let's find the x, the r. So don't forget that x is equal to r cos theta. So the x, the r, so that will be equal to cos theta. And don't forget that y is equal to r sine theta. So what will be the y, the theta? So the y, the theta will be equal to r cos theta. Okay, because if we differentiate sine theta, so we're going to have cos theta. Okay, next one, let's find the x, the theta. So the x, the theta will be equal to negative r sine theta. Okay, because if we differentiate cos theta, we're going to have negative sine theta. And then the last one here is the y, the r. So if we differentiate this, we're going to have sine theta. Okay, so let's input that into this formula right here. So the x dr, which is cos theta, so we have cos theta, then multiply by the y, the theta, and the y, the theta, that is r cos theta. So we have cos theta multiplied by r cos theta, then minus the x, the theta, and the x, the theta is negative r sine theta. We have negative r sine theta, then multiply by the y dr, which is sine theta. Okay, so which is sine theta. So let me clean this part. Okay, so we're almost done, guys. All right, so we have the determinant of the Jacobian matrix to be, so cos theta multiplied by r cos theta will give us r cos square theta, and negative times negative will give us positive. So then r sine theta multiplied by sine theta will give us r sine square theta. Okay, so we can factor out r, so we'll factor out r, that will be r into bracket cos square theta plus sine square theta. I remember that cos square theta plus sine square theta will give us 1. So we have r. That's the determinant of the Jacobian matrix here. Okay. Then we have, using this formula right here, so we have the x, the y is equal to the determinant, which is r, multiplied by the r, the theta. So that is beautiful. That is beautiful. So we're going to rewrite the integral I squared as follows. So before we move to the new page, let's do it here. So we're going to have I squared equals integral from 0 to 2 pi. Don't forget, I said theta is in between 0 to 2 pi for the what? For the x-axis. That's why we have 0 to 2 pi here. Then integral from 0 to infinity of e raised to the power of negative r squared r d r. So you'll be wondering, the r of the theta, sorry. So you'll be wondering how we have negative r squared here. Okay, so let me explain that before we move to the new page. Now, from this part, we have x squared plus y squared. And then x is r cos theta. That is r squared cos square theta. That will be x squared. Then plus y squared, and y is r sine theta, so that will be y squared. That will be r squared sine square theta. So we can factor out r squared. That will be r squared into bracket cos square theta plus sine square theta, and cos square theta plus sine square theta will give us 1. So we have r squared. So that is how we have this r square right here. Okay, then our dx dy, so that's r dr d theta. Do you understand now? So that is beautiful. So let's move on, guys. We are almost done. So let's move to the new page. So the new page, so this is what we have now. I square equals integral from 0 to 2 pi, then the integral from 0 to infinity of e raised to the power of negative r squared multiplied by r dr. So we can integrate this dr of the theta, okay, using the partial, integration by parts. And then before that, we're going to have I square equals integral from 0 to 2 pi, then the theta, then integral from 0 to infinity of e raised to the power of negative r squared r dr. So we integrate this separately and also integrate this separately. So if we integrate the theta, we're going to have the theta, we're going to have theta, so that would be theta from 0 to 2 pi. Then if we integrate these separately, okay, before that, let's just evaluate this. So we have integral from 0 to infinity e raised to the power of negative r squared r dr. Okay, guys, so then if you input your 2 pi, the limit, so that'll be 2 pi minus 0, so we're going to have 2 pi. So we have I squared equals 2 pi, then multiply by integral from 0 to infinity e raised to the power of negative r squared r dr. So we can make use of integration by part here, or we make use of substitution. So I'll be making use of substitution right here. Okay, so I will let r squared be equal to u. So if r squared is equal to u, so 2r dr will be equal to du. So that is r dr is equal to 1 over 2 du. Okay, so we have I squared is equal to 2 pi. Then multiply by integral. The limit is not changing. So that will be from 0 to infinity. E raised to the power of negative u, then multiply by. So r dr is 1 over 2 du. So multiply by 1 over 2 du. So I can just bring the 1 over 2 outside here. So we have the u. So that will be 2 pi. Then, so 2 can cancel out 2. So we don't need to write 2 pi again. So we're going to have pi. So then integral from 0 to infinity of e raised to the power of negative u. So that will give us 1. Okay, you can do that. So we're now going to have I squared is equal to pi. So to find I, we have to take the square root of both sides. So taking the square root of both sides, we have I is equal to root pi. So we have our mysterious answer, which is square root of pi. Okay, guys, so if you like this kind of video, please don't forget to subscribe to my channel for more interesting videos. Okay, guys, thank you for watching. Please subscribe, like, comment, and share. See you next time.